Hey everyone, as you might know, 1 month ago in the Xi'an Nationals, China teams achieved the max score of 434 points. That is the highest score that any team can get in VEX IQ mix and match. So as you can see here, crazy score. We have a 121 stack, a 91 stack, completely full middle goal, as well as completely full triangle goals as well, with two 3-color stacks in each. And as you can see here, that is 434 points. We actually saw 3 of these matches in this event, and there is also some secret tech on this robot that we will be covering later in this video. All right, everyone, jumping into the match. So if my info is correct, both of these teams are from StemStar, which honestly kind of just solidifies them as the best teams in the world right now. And again, as I said, there is some really crazy tech on 921A Da Xiaobao's robot. So keep watching because we're going to fully break that down. Now, to get this match started, blue team over here, which is Da Xiaobao team 921A, does do a 121-point cactus instead of 110 points. Something we've started to see a lot more commonly, as we can see that stack over there. They put it on super cleanly, no interruptions at all, 17 seconds, super fast. But you can get the max score of 434 points either way, 121 or 110. And as we can see, just 25 seconds into the match, that 91 is also done. A bit slower this time, but and super fast. Da Xiaobao already getting those stacks into the triangle. And also, I'm pretty sure both of these robots are 2-motor drivetrains. So the fact that they're moving this fast throughout the match is pretty crazy. They're getting those starting pins super accurately. Now, at this point in the match, there's not really a lot of time left, but they still managed to execute that perfectly. And we can see that celebration at the end for the max score. So this match was honestly not that surprising. We saw 423 points in the first national competition, so it's not very surprising that we saw the 434 points here. But yeah, we can see they finished these triangle goal scoring at the end very nicely. All right, so now I do want to talk a bit more about driving, and basically that's the main difference from this match and this 423-point match that we covered before. I mean, the robots were pretty much the same, and they also had like the same speed, same everything. So practicing driving in your free time is very important, and it's super huge for high scores. These teams spend hours every week just working on their control of the robot, and you can really see it in matches like the 434-point run. Another big thing that needs to come out of driver practice is being able to look back at multiple runs and see what went wrong. You can see what needs to be improved or what went wrong in your matches that didn't get the score that you want. So early in the season, I saw a lot of teams that had to line up perfectly to beams just to clamp or drive forward super precisely for that beam drop. But now, if you look at the top teams, right, we can all see some kind of consistency mechanism here. When they drop that beam on, they go all the way back. We can literally see they go all the way back. Their robot is literally touching the standoff goal. And even though it's such a small detail, helps consistency a lot. Another thing over here, the 91 aligners. It's kind of hard to see from this angle, but it's basically this V shape that slots in, and it saves, I think, maybe probably over 4 or 5 seconds each match compared to teams that don't have these. And by the way, as the builder or the coder, you basically want to make the driver's job as easy as possible because they already have so much to focus on. And especially in less competitive regions like the US, you don't really need the fastest robot in the world to win. You just need a robot that's easily driving and can consistently hit a score that you think will win. And a good strategy I would recommend is to look at the competitions near you and see what the winning scores were, and then you can focus your driving practice and improvements around that score. Anyways, I feel like this flowchart is really helpful. So if you guys want, please maybe screenshot it and you can send it to your team. All right, so now that we've got this part out of the way, this is the part that everyone has been waiting for, the new tech. So Basically, a new tech is what we call the pass tech or the piston arm straightener. Basically, how this works is this is a much more simple version of the back tech. So we first showed the back tech about a month ago in my match analysis with Quasar from 3722U. And I realized that we didn't really explain back tech that well before. So here's a quick explanation. Back tech stands for beam and arm coupling. Normally the 180 arm is hinged, so it stays more parallel to the ground. And that makes it much easier to stack, especially as these scores are getting higher, teams are moving faster. Claw is getting more and more hinged and to stack faster. But the problem is when you lift the 180 mech to score in the triangle goal, if it is very hinged, then most likely the stacks will fall over. And once stack falls, those pins are basically completely useless. And in the triangle goal, it's even worse because it takes up space for other stacks. So BackTech fixes this by using a separate pusher, which is connected to the arm. You can see over here, the lift spins up at the same time as the arm spins up. And that green piece there is actually part of the pusher. So when the back tech is activated, it's almost like the hinge doesn't exist at all. And the angled 180 drops pins way more consistently. It's a tilted beam drop. So you can see it drops super well, no shaking or at all. And it's also used for grabbing starting pins. As you can see here, it's basically straight. The entire arm is straight. It's almost like there's no hinge at all. But the downside is that back tech is super heavy and overcomplicated. You have to design your entire lift structure, everything around it. So pass tech is way simpler, and it also has another use case that we'll talk about in a second. Basically, the piston is directly connected to the arm. As you can see here, this is a short piston and it's connected to the arm. So when it's normally stacking, right? When you want to have the hinge, the piston doesn't do anything. And this is because of a single acting piston. So this is an example of a single acting piston. They're much more common in V5. I've personally never seen these used in VEX IQ before. So basically how it works is the piston only has air going into one side. Usually you're used to having another tube at this end, right? But single acting only has it on one end, and in this case, it is the extending end. Single acting cylinders are powered outwards and then released with no force. It means that they don't need to constantly extend and retract it for stacking normally because it can do that by itself when there's no air going through it. However, when we want to straighten it, this piston can push with air, basically doing the exact same thing as back tech, but with only 2 extra parts compared to back tech's like 50. And for the solenoid, the other side, it's basically blocked or it's connected to another single acting piston. And yeah, it's faster, it's simpler, and it's much lighter than the back tech. Here's another example. This one is a bit longer piston. So if you want a longer hinge or a bigger hinge, you'll have a longer distance for it to go backwards compared to this one. This one is a short piston, so this is basically getting blocked once it reaches that position. And again, we can see the pass tech in use here. See how that's hinged originally. Once they're done stacking, when they raise it up, the claw is not hinged at all. It's almost perfectly straight. It's same thing as the back tech, and it drops in really easily. And then we can also see another use of it over here. As you can see, boom, perfectly straight. I'm pretty sure they also do it here when they get that starting pin. You can see the claw is angled upwards. And then when they get it, they just undo the air and it goes back to normal hinging. Now, for the second use of pass tech is when the 180 is flipping. As teams add more rubber bands and they start flipping on that beam faster, you can see that flip is super fast. Sometimes the normal hinge, like with gravity and all of that, it doesn't have enough time to react. And sometimes it'll miss. Basically, pass works throughout the entire rotation. We can actually see, it's kind of hard to see here, honestly, but it does activate. The claw does not hinge at all, and it's basically a perfect rotation 180, similar to the ones that we saw at the very beginning of the season with no hinge at all. And it basically automatically straightens the claw while flipping. And this lets teams add more speed to their clock flip without having to worry about the hinge at all, which just makes this so much more consistent. Again, adding to the fact of consistency. And I do think that we're going to be starting to see a lot of bots with this pass tech soon. All right. Anyways, guys, that is going to be all for today. If you guys enjoyed, please consider subscribing. And also, if we get this video to 250 likes, I will do a full breakdown of some of the new motor share robots coming out with a 4-motor drive base. That robot is super cool. So if we can get it to this 250 like goal, I will do a full breakdown on that. And make sure to check the description for all of the photos, videos, and events that we showed today. And also join our Discord to stay updated. And we'll see you soon.
Check my pants, they say true, man. Blue bands, blue bands, blue bands.